one. And even before I talk about Composite 101, I think it's important that you understand what's my level of experience for Composite 101. I used to work with Collins Aerospace at a business called Aerostructures, which is headquartered out of San Diego, Chula Vista. I worked in a team called Global Engineering, where we had a center in Mexicali, Mexico, Singapore, Bangalore, and San Diego. So the four centers, and I was responsible for program management of nacelle programs for more than, let's say, 6 to 8 different programs. I had a team of about 11 people, and I used to joke it's a cricket 11, right? And we did some amazing work together. The first and foremost program that I worked on was the A320neo. I worked on Neo, I worked on 787, I worked on A350, I worked on C series, which now went on to become A220. I even worked on some of the most challenging programs, which are smaller programs, the Dassault Falcon 6X, the G400, and so on and so forth. I've done many programs, and in the process I've learned about composites, and I'm going to try and impart a little bit of wisdom to all of you so that you can become better at composites. And believe me, I am not going to just talk about technology, but I'm going to talk about why is the technology important. So we'll start with why, and then we'll go deeper into what is the technology, how do you apply it, so on and so forth. And this is just the first module. We'll continue to have additional modules. You're going to have a lot of fun activities to do as part of this course. We have a great lineup of speakers that'll talk to you. We have a founder and CEO of a composite manufacturing company who's, by the way, a PhD in composites. We have some very profound speakers from national laboratories. We have a volunteer who works with SAMPI, and we're also trying to get some volunteers who work with TPRC, Thermoplastic Research Consortium. So this is going to be the highest quality education that we can provide you. And the reason we are doing this online is very simple. We want to give access to this education to all parts of the world. And of course, we want to give the access to tier 2 and tier 3 cities. It may not be physically possible for you to come to Bengaluru or big cities, but that's fine. You can do this on your mobile phones. All right, so let's dive in. Okay, so let's talk about composites. Which was the first plane that used composites the first? 787. 787 was the program that is again in news recently because of the Air India accident. But believe me, 787 is one of the best birds built out there. And yes, Boeing experimented with the composites for the first time on 787, and the program was delayed significantly. But it's a program of significant value. They built the airframe, which is 20% lighter than aluminum, the previous versions. The fuel efficiency is directly proportional to the weight, and your specific fuel consumption goes out by 20-25%, and that's what they delivered over aluminum jets. The maintenance costs are significantly lower, about 30%, because your corrosion, fatigue issues that you have with aluminum tubes, you don't have it here. And your service life is much, much longer. You have a longer fatigue life, you have reduced inspection, and extended usage. Now, it's not just 787 that did that, but even A350, Airbus did that on their A350 platform. And believe me, the next generation single aisle platform that both Airbus and Boeing are thinking about, which is far out, I believe it's out there in 2032, will have composites. And there's a significant amount of research going on. Today's composites are the thermoset composites. So essentially they're built with the carbon fiber, and they're built in a shape and form that it stays in. Now there's a significant amount of research, and primarily GK and Fokker is really good at it. TPRC is the Thermoplastic Research Consortium. The research is around using reusable thermoplastic. That way we can reduce the carbon. It's all about Clean Sky Initiative. Also, the other advantage for all the companies is the cycle times go down drastically. Today's composites are put in autoclaves. They are in autoclaves for hours, which means the time lost is money. And autoclaves are bulky equipments, millions of dollars worth of equipments. So there are processes around stem forming. And I've seen some of that work being done at Collins Aerospace. But sheet metal, just like sheet metal, you can stamp a part, you can stamp a thermoplastic part. Now you can do flat surfaces using that, but you would need joining or welding processes to form complicated structures. And again, Collins Aerospace is where I would go back. They've done some phenomenal work. You may even see it in Paris Air Show, and I've seen pictures of Paris Air Show that's going on now. There is a thermoplastic fan cowl that's out there. They've already built a demonstrator thermoplastic fan cowl with the thermoplastic composite. So that's the past and the future of the composites. This is an area we will dive in further. We'll talk to you about practical, hands-on learning that you will not get anywhere outside.